For 10.7, we are still looking at polars, but now we're actually looking at our graphs. You will need to have already done, or at least attempted, this packet in order to do this video. So at the very top of the packet, it does ask for your independent and dependent variable. Your independent should be your theta. Your dependent should be your r. And then you are going to be filling in this table. You can do this just simply by looking at your unit circle and then multiplying by 4. I would not do it with your calculator because it will give you all sorts of decimals, and I do want your table to have exact answers. I would, however, make sure your calculator's in radian mode, though, for future things. So when I plug in 0, sine of 0 would be 0, because my y-coordinate there is 0, times 4 is still 0. At pi over 6, sine of pi over 6, so that would be about right here, is 1/2 for my y value. Multiplied by 4 is 2. So again, I could make sure I'm graphing these. So when my theta was 0, I was at 0. That's basically it being at the center. When my theta was at pi over 6, I was at 2. So 1, 2. When my theta is at pi over 4, sine would have been radical 2 over 2. But I'm multiplying that by 4, so I get 2 radical 2, which I do want the 2 radical 2 in your table. I went ahead and said that's about 2.8. That way I had an idea of where to put my point. Pi over 3. Sine of pi over 3 would have been radical 3 over 2. Multiplying by 4 should have given me 2 radical 3, which is about 3.5. Pi over 2, my sine there would have been 1, so times 4 is 4. You are going to repeat that for your angles over here. Just as an idea, I'm going to jump around a little bit, but we'll do the pi over 6 ones. This would be 5 pi over 6, which my sine was a positive, oh sorry, this is 5 pi over 6. My sine is a positive 1/2. Multiplied by 4 would put me at 2. And I'm doing this one just because they're whole numbers, so they're going to be easier to see. Down here it's 7 pi over 6. My sine is a negative 1/2. So when I multiply by 4, I get negative 2. So I'm this direction, but actually I go backwards 1, 2, and I do land back on that same dot. So remember, when you have negative, that just means you're going backwards. And then for 11 pi over 6, again, my sine would be a negative 1/2. So when I multiply by 4, I'm facing this way, but I go backwards because it's negative 2. So I do land right back there. If you have not yet, go ahead and fill in your table and get your graph. There's the rest of your table. Notice I use the exact values for my table. Once I'd gotten the decimal written down once, I didn't need to keep writing it down. I understand that a negative 2 radical 2 is just going to be a negative 2.8. And then there is my graph. It's a circle. How do you think the value of A affects the graph? So remember, when you are looking at this, this is R equals A sine theta. So now on your calculator, try changing A. So plug in the 4 so you can see what it looks like on your calculator. And then try changing your A value. It should change the size of your circle or affect the diameter. Now try using cosine. So it's still A times cosine of theta. So try different numbers for A, see if it still has the same effect that it did over here for sine, but see what the cosine does as well. It should affect which axis it's on. So your sine goes with your y value and is kind of centered over your y-axis. Your cosine goes with your x value and is centered over your x-axis. Looking at that back of that page, I tell you some specific things to change to your graphing calculator. Do not type in 6.2831853. One that's rounded. You can see the dot, dot, dot there. These are all in terms of pi. So this is actually going to be 2 pi. Same for your 0.1308996. Please don't type that in exactly. Some sort of fraction of pi. So if you're not sure, try a couple. So maybe pi divided by 6, because that seems like a good number. Nope. Pi divided by 12. Nope. Pi divided by 24. Ah, yes. So what that is basically doing, if you go back and look at this graph, means that it's going to plot a dot, like this would be pi over 12. So it's going to be plotting a dot as if you had one here too, a pi over 24. And one here, and one here. Like it was going to plot all those half spaces too, that way you get a more precise graph. All right, so now in your calculator, go ahead and explore, just like it says, a little bit more and get an explanation there for those. I at least have some sketches for you for my graph. They are all circles. The A is your diameter. I've said that already. Sine is going over your y-axis. Negative sign would just be down here in the bottom part. Cosine is going your x, and negative cosine's on the left. I have these as smaller circles just so that you can see that they're a different circle, but they also were changed with the A. But you should have a couple of different pictures there. And an explanation for all of these, even though I didn't answer part B. Once you have that, go ahead and do your table and your graph for the next one. You know how to fill in a table and plot points. Here is mine, and I know that circle is kind of hard to see, and it's also not a circle. It has this little like dip, this little point right down here where it comes back in, so it's not completely rounded. This is called a limacon. And you are using either A plus or minus B times sine theta, or A plus or minus B times cosine theta. So use your calculator to explore those things it says in part A and part B. This is crucial for your project that will be your assessment for this half of this chapter. So make sure you're really following the explorations that I have on there. You really need to see how doing different things to your equations can create different types of graphs. On this back page, I'm going to run through some official names for some of these with you. So choose values for A and B so that A over B is less than 1. So what I ended up doing was 2 and 3 because I knew that 2/3 was less than 1. So I'm going to graph R equals 2 plus 3. And I'm going to do cosine for these just because we've been doing sine for all the other ones. When you graph that, so here's my graph here. Your horizontal distance, so how far it comes out, and it's cosine, so it is going horizontally, should be A plus B. So that distance there is going to be A plus B. And this will be true for any situation where A over B is less than 1. So if you had 3/4, 5/7, anything like that, you are going to come up kind of like the height of this thing. In this case 2, but a distance of A. So whatever that first number is will tell you how high up you're gonna come. Okay, notice you have this little loop here. This loop is b minus a. So in this case, 3 minus 2 told me to come out one spot for it. So it looks like a limacon because it has that little like dip back there. So it is a type of limacon, but it has a loop. So it's limacon with inner loop. There will be lots of cool things you can create with these. Now, because I'm using a horrible device over here to draw these, mine is a little wonky as far as being stretched. It should probably be a little bit more rounded, kind of like that. For your next one, you're choosing values for a and b such that a over b is 1. So basically they need to be the same. So I did 3 over 3. So really I'm doing r equals 3 plus 3 cosine theta. So again, it's going to be going sideways. This distance here, from beginning to end, is still a plus b. So 1, 2, 3, 4, 5, 6. So that distance there is still a plus b. Your vertical, where it hits the axis, is still a. And technically, if you remember, that loop was b minus a. Well, here if I did 3 minus 3, that's 0. So I don't actually have a loop. Let's see if I can't draw a better one over here without the graph. A little bit like that. It kind of looks like a butt, especially if you turn it sideways. Or if you turned it like vertically sideways, not quite as pointy as that, it almost looks like a heart. So it is called a cardioid because it's heart-shaped. The next one, you want a over b to be more than 1 but less than 2. So I thought of like 4/3 because that's more than 1 but less than 2. So my equation is r equals 4 plus 3 cosine theta. Just like it has for all of these, your y-axis is going to be coming up that a distance. So in this case, it's 4. And it's going to be coming over your a plus b, 1, 2, 3, 4, 5, 6, 7. So that distance is a plus b. And this inner loop was b minus a. But if I do 3 minus 4, that's actually negative 1. So I do go backwards. I'm not going to put that in there. But think of it as, if you can remember, it goes backwards, a minus b. But I would rather probably just say b minus a. And since it's negative, I know I'm going to be going backwards. So this one's going to be kind of dimpled and then come all the way around like that. Almost like that. This is called a dimpled limacon. Then our last one, a over b has to be more than 2. So I did 7 over 3. So I have r equals 7 plus 3 cosine theta. So when you do this, you're going to be coming up all the way to a again. So that would be 7 for this one, and all the way down. You're going to be coming all the way over to 7 plus 3, which would be 10. And then you're going to be doing b minus a. So 3 minus 7 would be negative 4. So we're coming back to here. So it doesn't actually loop or dip or anything. It's just convex all the way around, kind of like an egg. And it is called a convex limacon. For all of these, if you look at my actual key, there's some better pictures for them.